Welcome to Vignana Jyoti Mathematics YouTube channel. Today I would like to explain tangents and secants. In this lesson I would like to explain one problem. You can find in our textbook it is as problem 4th in exercise 9.3. Problem is like this. Here you have a figure. You see this here A, B, C, D is a square whose side is 10 centimeters. You see, find the area of the shaded region from the figure. Here, what is the shaded region? You can clearly identify the shaded region is these blue colored parts. How many parts are there? 1, 2, 3, 4. So you have to find the area of these 4 blue colored shapes, isn't it? So in this problem, the value of pi has given, you have to take 3.14 while calculation. Side of the square is 10 centimeters. Now this problem has 3 or 4 methods. I would like to explain 3 methods in this video. You have to watch up to end of the video. Okay, now I would like to explain one shortcut method. I would like to explain how the given figure formed. This given figure is formed like this. You see, what is this? This is exactly one semicircle. And what is this? This is another semicircle and semicircle and semicircle. You see here 4 semicircles touches with each other. You have one green color, one blue color, one yellow color and one red color. These 4 semicircles touches with each other. Therefore, you can get the shape. You see what is the shape as given in the problem is same to that, isn't it? Now here observe. So how many parts are formed here? Okay, you see how many parts are formed here? That is 1, 2. That means this space is 2. Then 3. Then 4. Then 5. Then 6, 7. Then 8. So how many parts are there here? 8 parts. These 8 parts are included in this square only. So here clearly you have one square. You see one square and 4 different colors semicircles, isn't it? So here now how can I find the solution? Okay, come to solution. First of all, you have to write down RTP. What is RTP? What you have to find the shaded region. According to the given problem, what is the shaded region? According to the given problem, the area of shaded region is equal. So here see, here the glowing part 1, glowing part 3, glowing part 5, glowing part 7. Going to find these 4 shapes. Here the glowing shape 1, part 1, part 3, part 5, part 7. So clearly we are going to find the area of part 1, this glowing part 1, part 3, part 5, part 7, isn't it? Is it clear? Now you have to write down like this. Area of shaded region is equal. This is what we have to do. We have to add these 4 areas, isn't it? Therefore plus, plus, plus. Therefore area of shaded region is equal 1 plus 3 plus 5 plus 7, isn't it? Now, so in continuation this problem, now what is given? So what is given? Area of square is how much? 10 centimeters. Is it clear? So here this is, see here, this is the side of the square as well as this is the diameter of the semicircle. So he see this is also diameter of this semicircle. So this is also the diameter of this semicircle, isn't it? Therefore the diameter of the semicircle is how much? Can you guess? It is nothing but the side of the square. It is also 10 centimeters. But we have to find the radius of the semicircle. If diameter is 10 centimeters, the radius will be clearly 5 centimeters, isn't it? Then what is the next step? You see here, shortcut method. Method 1, shortcut. Area of shaded region is equal area of 4 semicircles minus area of square. You see here, those students who are good at visualization and understanding, if you clearly observe at the beginning of the solution, this figure is formed by using of 4 semicircles. You see, the 4 semicircles are glowing. Sum of the areas of these 4 semicircles is clearly greater than the area of the square. That's why I am subtracting area of square from area of 4 semicircles. Why these 4 semicircles is greater than the area of square means, you see here, this big part comes in green color semicircle and yellow color semicircle. If you take this one, this part, this comes under red color semicircle and this also comes under yellow color semicircle. If you come here, this is also comes in red color semicircle and this comes also blue color semicircle. That's why these corner bits, what we are going to find, the parts 1, 3, 5, 7 are repeated twicely. That's why the area of semicircle is greater than. Therefore, if the area of say 4 semicircles gives how many circles? 2 circles minus area of square, isn't it? Therefore, you have to write down area of 2 circles. What is the formula? So, area of circle is pi r square. You have 2 circles, that is 2 pi r square minus area of square side square. Therefore, if you find 2 pi r square, it is nothing but 157. Side square means 10 square 100. It gives 57 square centimeters. So, if you understand very well, just it is a matter of 2 steps, isn't it? So, it is those students who are capable to understand and who are capable to visualize the figure, those people can do like this. If the students who are not able to understand this visualization, they can choose the next method. The next method is very different method. You have to watch it. Now, the figure is like this. You see, in method 2, I would like to bring each semicircle from the figure. So in previous slide, how the figure was formed. Now here, the figure was well established. Now I have to bring out the semicircles from this figure. Now you see here, the first semicircle, green color semicircle, it comes out. So what are the parts formed by using this green color semicircle? So you have 3 parts. Okay, now therefore you have to write down the one step. What is that? Area of green shaped semicircle is equal 1 plus 2 plus 3. So the area gives area of part 1, area of part 2, area of part 3. If you add the areas of 3 parts, if you add the areas of these 3 parts, you will get green shaded semicircles area. Then you will bring out, I will bring out this blue color semicircle. See how it comes? Yes, very good. But the parts that are formed by this blue color semicircle is nothing but 4 and 5. You see here 3 is glowing. Why I opt this animation? Here 3 is a common part of here 3 is a common part of its green color semicircle and blue color semicircle. Therefore, you see, I have explained in the previous slide, this part comes 2 times. So in green color semicircle and blue color semicircle. Okay, that's why I just bloom like that. Now what is the area of? Now area of blue shaded semicircle is equal to, what are there? 3, 4, 5. Therefore 3 plus 4 plus 5. Okay, thereafter you pick out the red colored semicircle from the original figure. So you see which parts comes under red color semicircle. You see clearly this 5 is glowing. That means the glowing 5 comes under this glowing 5 comes under 2 semicircles. In which semicircles? It is in blue color semicircle and it is in red color semicircle also. Therefore, this 5 is common to this red color semicircle and this blue color semicircle. Therefore, you have to write down area of red shaded semicircle. isn't it? It is nothing but 5 plus 6 plus 7. You see 5, 6, 7. Here also 5, 6, 7. So thereafter the last one you have to pick out. Therefore, what are the parts here? Here you have 3 parts, isn't it? Here 1, it is a common part. Here 7 is also common part, and 8. Therefore, area of orange shaded semicircle is equal 7 plus 8 plus 1. Okay, isn't it? Now I am going to find the total area of these 4 semicircles. So what is the total area of these semicircles? How can you get the total area of these 4 semicircles if you add this one, this one, this one, and this one? Now the step will be like this. Area of 4 semicircles is equal, first I will take 1 plus 2 plus 3, then blue color 3 plus 4 plus 5, then red color 5 plus 6 plus 7, then yellow color 7 plus 8 plus 1. Now here you see, here you have 2 threes, here you have 2 fives, here you have 2 sevens. That means 3 and 5 and 7 comes at twice. So I have keep these 3 at the end, and I have to keep this 5 at the end. Now I have to keep this 7 at the end. To write down 1 plus 2 plus 3 as it is, then 3 write down at the end, then you have to write down 4 plus 5 here, then this 5 you have to write down at the end, then you will take down 6 plus 7, have to write down this 7 at the end. Okay, therefore you have to write down 8 plus 1 here only, isn't it? Now you see here the underlined part, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. So these 8 parts area from the figure, these 8 are internal parts of the square. Whenever you combine these 8 parts, the outer square will be formed. Therefore, the area of sum of these 8 parts gives the area of the square. You see, so area of 2 full circles, that means 4 semicircles gives 2 full circles. That gives area of square. Later you have to write down 1 plus 3 plus 5 plus 7, isn't it? These are the repeated parts. And the RTP is also, we have to find this 1 plus 3 plus 7. So according to our RTP, we have to find this 1 plus 3 plus 5 plus 7. Therefore, I would like to transpose the area of square to LHS. You see in next slide how it comes. Okay, the area of 2 full circles minus area of square is equal 1 plus 3 plus 5 plus 7. So the area of 2 full circles. So 1 full circle you have pi r square. Pi means 3.14. Here r is 5 into 5. Here we have 2 full circles. That's why we will multiply this pi r square with 2. Is it clear? Then minus area of square, it is nothing but 10 square. If you calculate this, you can get 157.0. It is nothing but 157 minus 100 is equal to 1 plus 3 plus 5 plus 7. If you subtract, the required area is equal 57 square centi, isn't it? Here 1 plus 3 plus 7 means required area. So this value is equal to how much? 57. Therefore required area is also 57 square centimeters. So this is the second method. This method can understand any student, even below average student also can understand this method. Okay, then we will go for third method. Now I am going to explain one more method which is frequently used in your classroom. The problem solved like this. You see here. So this is the figure. According to our problem, this is the required figure. We have to find sum of this part and this part and this part and this part. Strategy is like this. Area of shaded region is equal area of square. Square means the outer line. You see, the outer line forms square, isn't it? So this area of square minus area of 1 plus 2 plus 3 plus 4. You see here this part is 1, this part is 2, this part is 4, this part is 3. Can you understand? If you subtract 1, 2, 3, 4 from the area of the square, whole area, definitely you will get this one and this one and this one and this one only. Okay, from that I have to explain like this. You see here, how many semicircles are there? Here we have 2 semicircles touches at one point. Okay, these 2 semicircles are placed at horizontally. If I remove these two semicircles from this whole figure, now what I am going to do? I am going to remove these two semicircles from this whole figure. Then what happens? You see like this. The figure will be like this. Whenever you remove this one, you will get like this. Whenever you remove this one, you will get like this. Now you have this shape. This is nothing but 1, this is nothing but 2. According to the problem, this one are equal, and this 2 and this 2 are equal. Area of square is clearly noted. Why? Because it is the area of square is 100, side of square is 10, therefore this area of square is 100. So you have to find the area of 1 plus 2 plus 3 plus 4 at first. So at instant I would like to find the area of 1 plus 2 at first. So how can I get this part 1 and part 2? What I have to do? I have to just see like that. Area of 1 plus 2 is equal area of square. That means the total area minus area of circle. Why I am telling circle? Here these two semicircles forms a circle. Isn't it or not? I will bring out these two semicircles from the figure. So you will bring out two semicircles means you bring out one full circle. That's why you have to subtract area of circle. Isn't it? Therefore, area of square is 100. If you calculate area of circle, it is nothing but 78.5. It gives 21.5. Now I will go to take two more semicircles. Here the two semicircles are vertically touches with each other, isn't it? Here I had taken horizontal semicircles touches with each other. Here I will take vertical semicircles which touches with each other. Now, if you remove these two semicircles, can you imagine the figure? The figure is like this. You see here, this is part 3 and this is part 4. So we can get this part by removing this semicircle. We can get this part by removing this semicircle. That means we are removing two semicircles from this whole square. That means I had removed one full circle from this square. Therefore, how can I get these two? If I subtract the area of this circle from this square, isn't it? So can you get like this? Area of 3 plus 4 is equal area of 1 plus 2. Why? Because how can you get 1 plus 2? If you subtract area of circle from area of square. Here also the strategy is you have to subtract the area of square from the area of the square. That's why I don't go through the calculation. So here part 1 plus part 2 is how much? Part 3 plus part 4 also that much. That is the technique. Now you have to part 1 plus 2 plus 3 plus 4. Here you will get the area of 1 plus 2. Here you will get the area of 3 plus 4. Now we are going to conclude the answer. Okay. Area of shaded region is equal. I have already written the formula here. Area of square, it is nothing but 100. 10 square 100. Thereafter this minus you have to write down minus. Thereafter area of 1 plus 2 plus 3 plus 4. 1 plus 2 is how much? 21.5. So here 3 plus 4 is how much? 21.5. Therefore 1 plus 2, 3 plus 4 is how much? 43. If you subtract 43 from 100, you will get 57 square centimeters, isn't it? In model 1, you will get 57. In model 2, you will get 57. In model 3, you will get 57. Majority of the students and teachers followed this method only. But method 2 is very easy to understand, isn't it? Okay. Thank you for watching this video.